In this video, I'm going to work through exercise 15 in chapter 3 in quite a bit of detail and do a few extra parts. It'd be a good idea for you to pause the video and read the exercise, copy down the basic details of the question, and then pick the video up to follow along with this solution. In any case, it asks what happens about a ball that gets thrown downward at 14 meters per second. This question asks only what's the velocity of the ball 3 seconds after it's thrown downward. So I put the ball at the top of a tall building, drew an arrow to indicate that its initial velocity is downward, and that's 14 meters per second. The first part of the question is, at time equal 3 seconds, what is the ball's velocity? There's a bit of a trick here, which is why I wanted to do this example for you. It's fairly easy to know that the velocity of the ball later in time is equal to the velocity earlier in time plus AT. You have a formula for that. It'd be pretty easy to plug in some numbers here and get the right answer, but maybe not quite for the right reason. What I want to stress to you is that these quantities, velocities and accelerations and distances, are all vectors and they have directions. And you have to incorporate the direction in your problem solution. So I'm going to always use the convention that whatever is up is plus and whatever is down is minus. So when I use this formula to figure out the final velocity of the ball, I'm going to respect that choice. And I'm going to put in minus 14 meters per second for the initial velocity because it's 14 meters per second, but it's down. And I'm also going to add to that AT, which is minus 10 meters per second squared times the time, which is 3 seconds. Notice that this is also downward. So both the initial velocity and the acceleration are down. I chose up to be plus, and when you multiply this out, you end up getting a velocity which is equal to minus 44 meters per second. Okay, you got 14 here, and then 10 times 3 is 30. So 30 plus 14 is 44, but it's negative, down. So what does this minus sign mean? It means that when the ball gets down here, wherever it is, it's also moving downward with a velocity which is equal to 44 meters per second. The point is, in a drawing, the arrow works to tell you the direction, but in math, you have to use a plus sign and a minus sign to get direction. So that answers the question that was asked, but I'd like to go a little bit further. Specifically, I'd like to figure out how far down the ball moved. Like, where is the ball? In other words, compared to where it started, where is the ball 3 seconds later? So that formula is from chapter 2, this one, V0t plus 1/2 AT squared. But again, we're going to continue to make these choices about the signs of things being up and down. So the initial velocity is still minus 14. The time is still 3 seconds. Then you got to add 1/2 times minus 10, don't forget the minus, times 3 seconds squared. So I'll just tell you what you get here, but it'd be a good idea if you were to figure it out. Let's see how it would work. You need 14 times 3, but it's minus because the initial velocity is down. And A is always down, acceleration due to gravity. So 1/2 times 10 times 3 squared. By the way, the squared only attaches to the 3, so you got to square that first. And I get minus 87 meters if you solve that out. So where is the ball? it's 87 meters below where it started from. You can see that the distance vector, which starts where the ball started and ends where the ball ends, is also pointed down, and that's why that comes out negative. Now I might want to ask you a question about what happens if instead of throwing the ball downward at 14 meters per second, you throw the ball up at 14 meters per second. How does any of this change? So the question here would be, how fast is the ball moving and where is the ball if instead of throwing it down at 14 meters per second, you throw it up? So up at 14 meters per second. How does any of this change? Well, the only thing that changes here is that instead of having minus 14 meters per second for the initial velocity, you would have plus 14 meters per second. And the only thing that changes here, well, nothing changes here because the acceleration is still downward. In free fall, A is always downward at about 10 meters per second squared. So that's always going to be minus if you stick with my up as plus. So why don't you try to do this? Instead of putting minus 14 here, you're going to put plus 14. I find that if you update the numbers, you're going to get a final velocity which is minus 16 meters per second. So is the ball moving up or down? Well, in this case, the ball went up first and it's on the way back down. You can tell that it's moving down because V here is minus. So that's how you know the ball is moving downward. Now what about the distance? You're going to plug everything into this formula again, except now instead of putting minus 14, you're going to put plus 14 meters per second and multiply it all out, and you're going to end up with minus 30 meters. In this particular case, we see that if you threw the ball up at 14 meters per second and ask what's the ball doing 3 seconds later, we find that in fact it went up, reached its maximum, and then came back down. So it's below where it started and it's moving downward. So the sign of the velocity tells you whether it's past its maximum point. So as the ball rises up, the sign of the velocity vector is plus because it's moving up. And at its highest point, the velocity is equal to 0. Then it starts falling back down, going faster and faster as it goes. So I have one last extension to this. How high does the ball go? So think of it like this. In the case where we threw the ball upward, the ball rose to some maximum height, and then it started falling back down. We caught it 3 seconds later, so that's when it was maybe here, so part of the way down. How high does it go? In other words, what's this maximum height? So if you throw a ball up at 14 meters per second, how high does it go? Well, the trick to solving these is to realize at the very top, the velocity of the ball is instantaneously 0. First, the ball is moving up, so its velocity is plus. Then it's moving down, so its velocity is minus. But at the maximum point, its velocity is 0. It's important to realize that the acceleration, however, is still minus 10 meters per second squared. That's always true at the top, at the bottom, well, after it leaves the hand of whoever's throwing it, and before it hits the ground. Whenever gravity is the only thing doing anything, the acceleration is minus 10 meters per second squared. So, how are we going to figure out how high it goes? Well, I can think of a two-step process. Since I know that V0 plus AT equals the final velocity, I figure from this I could find how long it takes to get to the top. And then I could use the formula distance equals v0t plus 1/2 at squared to figure out the time, to figure out how high it goes. So I'm thinking of a two-step process here. I'm going to use this one to figure out how long it takes to get to the top, knowing that the velocity is 0 at the top. So I find that if this is 0 and so we could just plug things in. How about that? 0 equals plus 14 because we're doing the up. Okay, plus minus 10 times t. You got to solve that thing for t. So you would subtract, so you're going to do minus 14 equals minus 10t, and then divide both sides by 10. So divide by minus 10, divide by minus 10. You're going to find that the time is equal to 1.4 seconds. So that's how long it takes to get from the launching point to the highest point. And then to figure out how far up it went, we can plug things into here. So up at 14 meters per second, the time is 1.4 seconds. The acceleration always minus 10 meters per second squared in free fall. And you got to multiply all these numbers out. Be aware that the 1.4 has to be squared, and then you got to multiply by minus 10. But if you do these things carefully, you find that the distance is plus 9.8 meters. So what does that mean? The up means above the starting point. So we have figured that the ball will rise up 9.8 meters, and then it will start coming back down. After 3 seconds, it's like here. So that's a pretty detailed example of how you can apply the ideas of kinematics from Chapter 2 to objects that move up and down under the influence of gravity.